whether I can trust the communication is generally where the zero trust moniker comes from in terms of our state of security and controls. So what I was going to do is just kind of express a little bit of a why we're taking the stance that we're taking, and then give you a little bit of a sense of how HashiCorp can look to partner in helping you address concerns around when and where do we extend trust within IT. So it's going to be more about the challenges in the space and some of our thoughts on it, more so than it's going to be any sort of like product strategy or deep dive. We can do that. I would love to have that conversation with you. So, feel free to reach out and we'll get it done. For those of you who are new to Terraform or to HashiCorp in general, HashiCorp really kind of emerged out of a couple of consultants who were really trying to help companies automate. And they were actually originally just kind of serving customers as programmers and operators, and then got tired of repeatedly rebuilding systems for the various clients they were serving. So if I was working with a Windows organization, I would have to like reinstall an operating system, get a golden image that could get onto the network. And we were just taking so much time setting up our workstations that it would just taking too long to actually deliver anything of value. So I start building things like Packer to bin pack OS images, and then something like Vagrant to stand up a desktop environment really quickly without having to go through all the work of installing and configuring and all of that. Well, ultimately, they really began to recognize that this is a challenge just holistically in the industry. And so Terraform begins to extend that into really distributed systems. How can I deploy to any infrastructure, larger scale systems that do more for us, networking and storage and compute and et cetera, et cetera. And then along the way, we began to see that there were other elements that we could begin to address, like secrets management, like encryption. Can I instill in this automated deployment best practices for connectivity, trust, identity management, et cetera? And the answer was yes. Let's kind of continue to build out the portfolio in such a way that we can extend all of those best practices into your automated deployments. So that's really who HashiCorp is, and how our product set has continued to expand as we expose new things, new challenges. We simply begin to build another utility that can help address that particular concern. So the way that this is going to play out for us as we talk about what most enterprises are looking to do is to go a lot faster, to capitalize on the fact that we have cloud dynamic resources available to us. The cost of compute has declined incredibly through cloud native models. We've seen the fact that we can actually kind of use rental-based models to get capacity for a short period of time and then destroy it. The challenge is our IT processes were never set up to allow us to do truly sort of ephemeral. So if I'm going through this long ITIL, ITSM sort of process and multiple tickets and lots of different teams in order to provide a provision environment, I'm not really set up for like a quick build out and tear down without a lot of long kind of existential conversations about ROI and justifying the network topology that I'm asking for, or using a tool that wasn't approved by an EA group and so on and so forth. We weren't really built for that level of dynamism if we're older than, say, 30 years old as a company. But we need to be able to drive greater levels of innovation, and innovation requires an environment that drives out the cost of experimentation. Can I get an environment super quickly, try an idea, learn something with the customer, and do it over and over again? The companies that do that well outpace their competitors in the sector. And so we know that it's important that we get that iteration speed down, right? How quickly can I cut a new idea, get into production, test it, do it again and again and again. But along with that, we're challenged with new kind of a different take on our threat model. The more self-service that we make available, the easier it is to find holes, because there's lots and lots of moving parts, lots and lots of manual processes, lots of sort of click-opsy sort of approaches to the way that we provision infrastructure. So it leads to Gartner to say things that I don't think are very controversial. Like most breaches are going to be caused by inappropriate use of a cloud resource. Improperly configured piece of equipment is where we're going to end up with things like vulnerabilities. And so I just kind of called out a handful of sort of breach types to explain that I think as we think about trust, what we're really trying to do is shrink windows on attackers, reduce the amount of vulnerabilities associated with driving a self-service or innovative culture where we're turning around IT projects a lot faster. But we said it could be based on, we could introduce fragility because we have a SaaS provider that we rely on and we share data with the SaaS provider. We don't get breached, but the SaaS provider gets breached, like Cultura Cultiva with Facebook. So how do we negotiate the sharing of information and data? What are the encryption policies associated with that? How do we deal with identity? You know, am I going to allow the decryption of information once it leaves a particular subnet, as an example? One of the banks implemented something called data anchoring, where data physically could not be decrypted if it left a particular network segment. Those are kind of some interesting things for us to do to help mitigate these types of challenges, as well as how do we address, you know, a misconfigured S3 bucket. So I guess part of what I want to get at by talking about some of these breach patterns is that breach or threat or trust is a multifaceted challenge. It's not like I go buy a zero trust product and implement it and there we go, you know, we've solved this particular challenge. It's thinking through the delivery of IT holistically end to end and determining how and when do I allow or extend trust at each one of those layers. So I'm going to move pretty quickly through some thoughts here, but you know, as we look at our attack surface, I've got an application, it needs to share credentials, it runs an environment. I want that environment malware scanned. I want antivirus out there. I have all these kind of policies around cybersecurity that need to be implemented, APM standards, monitoring and management, visibility, logging systems. I'm tracking the drift in my source code, drift in configuration. You know, the point is that the landscape here that I'm trying to look at in order to mitigate threat and shrink windows for attackers is daunting, right? And the model has shifted quite a bit because generally I try to restrict the attack surface here by having a really hardened perimeter and then guarding the front door with seams and WAFs and gateways and all kinds of things.
Toyota Cedar Park.
To basically help us deal with ingress, right? How attackers have to come to that front door and we guard that front door with a lot of defenders. But as we move progressively more into cloud, we're introducing all kinds of holes into that perimeter. I've got trusted connections out to AWS and Azure and Google and maybe Oracle Cloud, SaaS providers, SFTC, and so on and so forth. So I have all these additional services that I'm consuming that all have kind of trusted connectivity into my network. Not to mention, like, the target breach was stores, right? I've got franchises out there in the world that are connected into, you know, corporate, and the attacker that led to the target breach came in through the HVAC system, which was trusted on the store network, and then rode the store network back to corporate in order to siphon off data. So perimeter controls become interesting. They're different. There's very porous networking in general, which leads us to say, well, there's not really a trusted zone here. Even if I go in and I segment the network, and you'll hear a lot of buzz around micro segmentation and how can we continue to segment the network and have thousands and thousands of layers of network boundaries in every single transaction, which is interesting from a complexity standpoint. It's a little bit daunting. But I'm not sure it's actually dealing with sort of the core principle shift that we need to move towards. And what we need to move towards is, I would like to very strongly identify whether you are a trusted member, somebody that I can talk to or not. And then based on that identity, if I can get strong enough with that identity, then I can unlock trust for you and let you talk to systems that you have authorization to talk to. So that's kind of the shift that we're gonna talk through. And largely, a lot of the shift is being driven because of the adoption of cloud. And I know initially we sort of rejected cloud outright. We really felt like it violates so many policies. We have change controls that are going to be violated here, policy, governance. How do we secure it? How do we make sure that it adheres to all of our corporate standards if it's all self-service and teams are getting out there? But it turns out we put too much pressure on software developers to deliver, and they just get the job done however they can get it done. And now, rather than having servers running under maybe an admin's desk, it's going to be running in an AWS availability zone. And then as we really started to see that there's value there, that we were able to iterate, and there were some experiences that got delivered through this sort of shadow IT function, we began to launch investigations on kind of what's the viability of making this stuff happen. And it led to us having these kind of enclaves of what I would call Gnostics, right? Different groups. Most enterprises, I feel, are in this world where they've got, I don't know, 50 different ways to take advantage of the cloud. It's platforms. I've got Kubernetes, I've got Cloud Foundry, I've got, even before that, if I'm dating myself, I had Heroku, I had Salesforce.com. I have all these various ways to simplify the delivery of applications to some form of infrastructure. And then I had teams that just really got into an individual cloud and really started to build practices around AWS native capabilities or Azure DevOps, CloudBees, or all sorts of different ways. And so we ended up with really a hodgepodge of approaches and operating models, which was a great learning period for us as enterprises. We needed to know what those capabilities were and kind of get a sense of what's really going to work well and not. But now we start looking at this and we say, what does this mean to us when it comes to like audit? And maybe you're a highly regulated business and you need to prove chain of custody and audit across systems and how they're being provisioned, who did, when, where, how they interact, and identity was attested, policy was enforced, and so on. But the other aspect of audit is, how do I mitigate breach? If I can't tell, so like if I look at SolarWinds as an example, and I'll just draw this one example, and then we'll get into sort of the meat of this. It was such an interesting breach because it came in. They did a malware phase 1 attack, came in on the patch. It lied dormant for 14 days to get through governmental quarantine procedures. Then it wakes up and downloads a phase 2 attack, and then they begin to do things like go out to VMware's VRA to create a new service, and then it goes out to Active Directory to create a credential to authenticate that service. And then it begins to siphon data off because now I've got a service on the network that's trusted, and it can start to assert its identity and pull information. Well, one of the reasons why that's such a difficult breach to deal with is because there was no centralized workflow for the way that identity is being attested. I have these various systems run by various groups with no real workflow other than maybe an ITIL ITSM like ticketing system to tell me that, whether a request came through or not. And if it's all coming through kind of API calls or self-service interfaces, that's even harder for me to track because it's falling outside of the ITIL ITSM sort of ticketing processes. So now, how do I audit? How do I have visibility? How can I track to see when and where these credentials were created? And so I think a lot of organizations are kind of looking at what's next, and I think it's going to look a little bit more like an industrialized approach. So if I have a centralized control plane for the way that we provision infrastructure on any substrate, any cloud, on-prem, off-prem, I want to treat those very, very similarly. Then I have a centralized audit plane through which I can apply things like policy, best practices for network connectivity, best practices for identity management and security. I can embed those types of things into the environment because I have control of the machining of my infrastructure, the way that it's going to get deployed, where, when, and how. Then if I add to that, that now that I've kind of distributed these kind of best practices in an industrialized manner, that anytime anybody asks for a server, it's going to be it's going to be our images that we have vetted and run security scans against. It's going to include malware and antivirus. It's going to include all of those things that are kind of standard for our delivery. And it's all going to happen kind of instantaneously because we're practicing infrastructure as code. Then I have a method by which I can distribute things like, say, a vault agent, which is going to inject my secrets into the environment, manage credentialing locally, identity, so on and so forth. I could also inject things like the control plane for networking and connectivity, authorization, authentication, routing instructions, et cetera, policies to enforce that communication, those types of things. And we're even seeing a lot of interest now at the developer desktop. So normally what we've done is, knowing how complex we are as IT shops, we will go after sort of a platform to hide that complexity, like Kubernetes or Cloud Foundry or something like that. And the challenge is that we extend this API and we say, hey, as IT operations, we're going to be good with everything below that API, but anything above that is your responsibility. So please don't burn down, the bank. That introduces, we're basically handing a lot more risk and responsibility out to the developer, which is pretty typical in a DevOps community. But progressively, what we want to do is include more change management, similar change management processes to the way that we manage the IT and operations. So it makes a lot of sense for us to include something where we define the intent of the application rollout, that we can audit, that we can apply policy to, that we can vet for appropriateness. I don't want you standing up environments on Friday afternoon when nobody's going to touch the system until Monday. We can have those types of policies and change management processes in place for the developer set as well, via some scheduling capabilities, right? Let's define it as code. Let's run audit against it. Let's run security scans against it and make sure that it meets all of our change management, ultimately in order to de-risk it so that we can be more innovative and move faster. So that's really how we think about these challenges. And if I were to kind of walk through a few things quickly, that infrastructure as code sort of approach is our product called Terraform. We're seeing a lot of customers, especially in highly regulated industries, do a lot more with us in the Terraform space, primarily because I want to make things go super, super fast, but I want to make sure it has all of the guardrails that we would anticipate. It also becomes sort of that linchpin in our ability to sort of distribute our best practices in a number of other areas. So maybe we have a particular standard we're implementing for service mesh. So I just want to distribute the clients for that mesh. I want them just to be native in the environment so that when services come in, they're dynamically registered. I go out and I get an identity for them. I ensure that that matches through multi-factor authentication. And now I can start having some automation driven that way. So that tends to be where a lot of our customers are starting, is in that infrastructure automation space with some policy controls to ensure that we're not exceeding costs or introducing frailty or risk into the environment. We then realize that in those configurations, we have secrets that have been exposed, because in order for us to tie this infrastructure together, I need to have cloud credentials for where I'm going to go provision. Maybe it's vSphere credentials that allow me to have administrative rights to create new resources. And I don't want to have those in the clear in my configuration code, because that ends up getting proliferated and it's a great attack vector. So what I want to start doing is I want to introduce something sort of between the systems that I'm working with and the clients that are doing the asking. And what I assert as I ask for a new credential is my identity. And I let Vault determine, are you in fact who you say you are? Run some multi-factor authentication. And then if there is an existing policy which says I have rights to that system, maybe I even let Vault go out and create the user ID and password on my behalf, and then hand me a ciphertext in the form of a token that I assert. So my code doesn't bear any resemblance to the actual secret that I'm using, but I'm still gaining access. And so that once we have that indirection between myself and the system that I'm trying to gain access to, I can do a lot of really interesting things there. So one of the elements of SolarWinds, and I'll pick on this just real quickly, is that credentialing, right? They were going out to Active Directory, creating a credential. We're starting to recognize that that is something that we have to start thinking about from a trust perspective. And I just grabbed this from a blog that was discussing the SolarWinds about the increasing misuse or theft of keys and digital certificates, trying to spoof either an existing service or, in the case of SolarWinds, a newly created service that was done by attacker who's hands-on keyboard and behind the firewall. And so some of the things that we can think about with something like Vault, once it's kind of in the middle, is I get an assertion of, hi, I'm a new service. Here's my PKI accreditation, which says that I should be trusted. And I can actually have Vault do some things like ask AWS for, is this workload tagged according to our corporate standards? Is it sitting on the correct subnet? I can ask a few questions underlying the AWS and see if it matches with what my expectations are for that certificate, as an example, or for that identity assertion, and make a determination then whether or not I would extend access rights and privilege. So I get another layer of indirection that lets me sort of vet whether or not this identity assertion is actually valid. And then the other thing there is that now I have kind of a centralized control plane by which I can kind of see these things. So imagine we've experienced a breach. We've done some forensics. Forensics can be very difficult without kind of centralized control planes. I'm going to do a wholesale audit and try to figure out when that patch came in, how long it was sitting on the network, and those types of things. But if I have the ability to kind of inject secrets or dynamically assign new secrets, to trusted identities, do I have a centralized control plane where I can say, hey, let's invalidate all, X509 certificates that are older than, that are say, were created between 2 weeks and 4 weeks ago. And then kind of flush those credentials from our infrastructure and actually kind of go through and have Vault dynamically create new replacement credentials for all of the valid IDs that are on our network. There are some interesting things I think that we can walk through, and I know I'm not getting into too many technical details, but I just want to kind of toss that notion out there, and then maybe we can have a discussion about how we can make that happen. Now, once I have an identity that has been strongly vetted, and through another layer of indirection, the reason I keep talking about that other layer of indirection is because it's easier to break into a database if I'm going directly at the database. It's much harder to break through the encryption wall if I have to also have a successful attack against Vault. Anytime I can add a multi-threat sort of approach, I'm actually improving my defense posture. I guess one last thing to mention about Vault, I think that's very important, is the fact that we can run encryption services through Vault. So even if I do get a successful attack on the database, if Vault was the one that was handling the encryption to the database, I'm still getting ciphertext. So I've got to go back and launch a secondary attack against Vault in order to prove my identity to Vault. And if Vault does accept me, if I'm able to spoof that, then I also have to have access to the database and get the decrypted ciphertext, I guess, get the information to clear. At any rate, we can do some really interesting things with that, with Vault between me and my target. Now, once I have that strongly attested identity, now I can go through and establish like communication policy based on the identity. So who are you and can you talk to me? And what policies should I be enforcing when you do talk to me? Do you need to go refresh a credential or a certificate? Are you calling me at the appropriate time of day? Is this a point of sale system for a store that closed at 6 p.m. and you're calling me at midnight? That looks anomalous to me. Let's trap that or deny that access pattern. And generally speaking, we're applying this sort of service mesh methodology where we're implementing proxies down at the endpoint where I can distribute authorization, authentication, and routing logic out to the endpoints. So they have a local record of who they can talk to and where those active IPs are. And so as we start talking about like ephemerality and what we're doing with microservices architectures, we're seeing that these IPs are going to come and go. What's going to remain consistent is more that DNS entry, that name, and I want to have identity attestation for that name. Is that name the right name? Is it sitting in the right availability zones? Is it tagged appropriately, so on and so forth? But I want to know that that name is the one that I'm working with, and the IPs behind that can move around quite a bit. And Console handles that through this dynamic registry. So I can see that a node has disappeared, a new node has come up, dynamically registers. I append that or update those IP routes, and then actually distribute that out to the agent so I know who I can talk to. Now, one of the cool things about what we're doing with Console is we're extending this across from kind of the newfangled way of doing things, as well as the legacy approaches within the database. I say legacy, they're all still very current, firewalls and load balancers and so on. And we've got a number of hardware partnerships so that we can sort of extend this thought behind sort of intent-based routing, like this web server can talk to a database, these names can interact with each other. I want to be able to extend that even when I have load balancers and firewalls that need to receive updates. So an IP has disappeared behind my web server, and I want the physical load balancer to receive that update. They can subscribe, like the F5 can talk to Console in order to receive updated information. There's a little bit of nuance in that conversation, so I'd love to have it with you. A couple of ways that we can do that, but it's really cool to see that we can drive dynamism across clouds and across paradigms, meaning it's Docker stuff on Kubernetes, awesome, right in the wheelhouse. It's VMs running on physical hardware within my data center. Perfect, sounds good. Let's do the same thing. So we got some really interesting things that we can do there. And then additionally, we're talking about audit and control and visibility and forensics, having a control plane that allows me to kind of monitor, manage, and work with all of that. Makes a ton of sense. So I'll stop there. There's one other element I think that's interesting to talk about, which is least privilege access. And we can get into that, maybe at another time. But this goes into sort of like day two operations and how we have operators that are going to be coming in and reaching out and trying to work with individual pieces of infrastructure and or a server or something that they've got to make a change to or work with. And we have all of these sort of convoluted ways of granting access and monitoring and managing that for things like threat or leaked credentials or so on. And generally speaking, that involves us dealing with a VPN, an SSH bastion host, maybe a firewall. I need credentials to the firewall. I also need credentials to the system that I'm actually targeting. And so I end up with a whole bunch of credentials in order to reach out to a single service. And we're trying to find a way with Boundary, which is a new product that we have coming out that allows us with a single identity attestation to tie you to the individual services that you have rights to work with, to greatly simplify the number of access channels that you have to go through by creating basically a secure target, a secure tunnel down to the target, and then allow you to take advantage of your identity management pieces. At any rate, I'll stop there. I know I ran a little bit long, and apologies there between you and the beer, but a couple of things just to leave you with. Identity is something that we got to get really solid on. Yes, we want to drive self-service, but we need to have sort of consistent workflows that are well understood and have policies associated and so on. And we really feel like Vault is one of those pieces that fits very nicely in helping you manage sort of identity across clouds, paradigms, platforms, et cetera. And then we're also going to do a better job of dealing with maintaining security through more dynamic assets. So what I mean by that is if we ended up with a breach when I've got malware that has been proliferating in the environment, can I replace entire fleets of infrastructure by calling on a known good image? That's a good way to go about trying to mitigate things like malware constantly repaving infrastructure. Yes, we can do that if we're doing it in an industrialized manner with something like Terraform. And then I really want to be clean on audit and compliance, not just for regulatory reasons, but also for breach mitigation, understanding, visibility. And let's use multi-factor authentication because individual credentials can be compromised, but let's figure out ways that we can add to that, that kind of credentialing approach. Part of that mitigation is going to be time to live on those credentials. Can I rotate those extremely fast? If no credentials living longer than say 30 minutes, then my breach window just went from 10 years to 30 minutes. That's one way to do it. And another way to do it would be to add additional layers to our attestation process. At any rate, thank you very much. I hope this wasn't too overwhelming, and I think it'll be fun to get into